Greetings students, this is Professor Watts, and today we're going to work through the Chapter 3 problems. At first I'm going to take you through some concepts that we're going to be working on with this material, and this is exciting because we're getting into some really powerful concepts that help us find relationships between data, and that's really what this is all about. It's collecting data and kind of organizing it in Excel is one thing, but then using some tools to tease out the relationships and tell us how one thing leads to another. That's what we're really interested in. So the tools we want to develop for this purpose, first off, correlation. So I want to talk for just a few minutes about what correlation is and how it works, and then we'll jump into Excel and start working problems where we'll use Excel's computing power to do the calculations for us. So I just want to get kind of a conceptual overview of what correlation is telling us. So we have in Excel a data set, and let's say we've got data on a sample of people, and we've got data on, let's say, their age and then their income. And we've got a ton of numbers in here in our spreadsheet, and this income would be in thousands of dollars maybe. So, okay, the actual values aren't important right now. We'll work with some actual values here in a minute. What correlation is going to allow us to do is say, how are these related? Now we have an initial expectation, and that's that as age increases, income does on average, because people have more experience, and with more experience comes more productivity, and typically in a market economy such as ours comes more pay. But we want to find out exactly how strong that relationship is. And that's what correlation is going to allow us to do. So work through the formula for correlation, then we'll think about it in terms of a scatter plot, which is going to be a visual tool that helps us to see the correlation, and then the formula is going to put an actual number on it, and then we can report that number, and we can compare correlations, and we can say how strong is a correlation between one variable and another versus a different variable in another. So for instance, we could put in a third variable here of IQ, and we could say, well, is there a relationship between IQ and income? Or we could put in a fourth variable of, let's say, schooling. How many years of schooling do you have, or what kind of degree do you have, and what's the correlation between that and income, so on and so forth. So we can then start to tease out, well, which of these things is the strongest predictor, if you will, of income. Okay, so when we think about the relationship between two variables, we want to start with this idea of correlation, but we need to back up a step, because correlation itself is based on the idea of covariance. Covariance between x and y, and we might say the x variable is the age, and then the y variable is the income in the example I'm using here. It could be any two variables that we think have some kind of relationship. And the formula is this. We're taking the sum, sigma, of each x value, we'll call that xi, minus the mean of all the x's, that's x bar, times each y value, call that y sub I, minus its mean. Okay, so this is the difference between each x and the mean, or what we call the deviation. And for the paired y value, so for instance in our spreadsheet we'll see that there's row 2 will have an age of 25 and an income of 47,000. We'll subtract that age from its mean, from the mean of all the x's, or we'll subtract that income from the mean of all the y's. Then those two values will be multiplied together. And then for every entry we multiply those two values together, sum them all up. Okay, and then all of that is divided by n minus 1. When we're working with the sample, we dilute the size of the denominator a little bit just for safety's sake. What we have here then is essentially an average of the products of deviations from the mean. Well, what the heck does that mean? Okay, to see how covariance works, I've just made I just made some scatter plots, and scatter plots are going to be a really powerful tool, and we're going to start working with them in Excel here in just a few minutes, but they'll help us think out what's going on with covariance. So remember, covariance is taking the sum of products of deviations from the mean. So every deviation of x from its mean. So let's start with this data set down here, or let's start with this little scatter plot down here, and let's think about where is the mean in x. The mean in x is going to be somewhere about, I'm going to just kind of guesstimate it right here. Okay. There's about as many below as above. They're pretty much evenly spaced. Okay, so there's the mean of x, and we're going to take the deviations, the value of each unit, how far the actual measurement is from x. So these ones are going to be negative because they're below x. These deviations here. And then these ones up here will be positive because they're above x. Okay, so we're going to take all those x deviations, and then we're going to multiply them times the y deviations. Let's think about the y's, and let me change colors here. The mean of the y's is maybe about right here. Okay, so there's the mean, there's y bar. Label this one down here x bar. Okay, so there's the mean of x's. We've got positive and negative deviations. Here's the mean of the y's. And again, if we're above, we've got positive deviations for y. If we're below, we have negative deviations for y. Okay, so down here we have negative deviations for y. And up here we have positive deviations for y. That's in blue. Negative deviations. Back here in green. On the right hand side we have positive deviations for x. And on the left side we have negative deviations for x. Okay, so what does that mean in terms of our covariance? This is the average of the products of deviations. Here we're multiplying positive times positive, so we get positives. Here we're multiplying positive times negative, so the overall result is negative. Here we're multiplying negative times negative, so we get positives, right? Here we're multiplying positive times negative, so we get negatives. Then we're adding all those up and averaging them. Well, look what's going to happen. And if we're relatively evenly spaced here, we're going to be adding positives plus negatives, that's going to cancel out, plus positives plus negatives, that's going to cancel out. All of these deviations are going to roughly cancel out, and when we add it all up, we're not going to have a very large number. We divide it by the number of observations, minus 1, and then we don't have a very large number, so there's going to be a small covariance over here. Going to be a small covariance. Okay. Now let's take a look at this other plot down here where we do sense a relationship. We see x and y kind of move together. Larger values of x over here, looks like they're generating larger values of y. And let's apply the exact same logic we just did, and we'll see how the covariance will reveal that. So I'm going to kind of guesstimate my mean for the x's somewhere right in here. Okay, then remember the deviations on this side are positive for x, and over here they're negative. And then take my y's, the mean is somewhere about in here, let's say. And then up here the deviations for y are positive, they're larger, the mean of y, and down here my deviations for y are negative. Okay, now when we think about the average of products of deviations, what are we going to get? Well, there's a lot of data up here where it's positive times positive, so that we're going to get positives there. There's basically nothing down here. There's a little bit down here, so we're not going to get anything here. We'll get a little bit here, which is going to be negative. But there's also a lot down here. Let me add a few data points here to stress this. There's a lot going on down here where it's negative times negative, which is going to be positive. Okay, positive times positive is positive. Okay, and there's not much going on here or here, so what are we going to get? Positive plus positive. We're going to add that up. We're going to have a pretty large number even when we average it out. So over here on this side, we're going to have large covariance. The upshot of all of this is that covariance is going to be a pretty reliable indicator of the strength of a relationship between two variables. One small problem with covariance, and let me bring us into a Excel file, and I said we might be testing age and income, so I just made up some numbers here, and I set them up so we will have indeed a positive covariance. So I got a data set of 10 points, I made up some ages, and I stuck some incomes with them. So let me show you what happens in Excel when we calculate covariance. Simple formula equals covariance dot s, because we're working with a sample, let's say of a we've drawn 10 people from a company that maybe employs 100 to see the relationship. So covariance, and then you just enter the array. You can click and drag array 1, comma, click and drag array 2. Okay, so here our covariance is 236,551. The problem with covariance is that it's very sensitive to units of measurement. So how can I demonstrate that? Well, I've done the exact same thing over here, except I've expressed age now in months, and you'll notice I just did that formulaically. I just took the years number from column A and multiplied it by 12. So let's calculate the covariance here when we've got age. Now we've got the exact same data. Age is just in months here. Maybe I should specify that. But it's the exact same data. We should find the same relationship, right? Well, let's see what happens when we calculate covariance. Sample covariance. Covariance sample array 1 is this now. Array 2 is this. And let me reveal that. Now our covariance is 2.8 million. Here was only 200,000. So now we're a whole order of magnitude larger. So covariance, you see, is sensitive to the units of measurement, and therefore it's going to be really hard to make apples-to-apples comparisons when we do different units of measurement, which we're going to frequently run into. So right? Because if we're looking at if we want to test the effect of other things on income other than age, we'll have years of schooling, we'll have IQ, we'll have where you live, all kinds of things. We're going to have covariances all over the place, and there's going to be no way to size them up side by side. Okay, that's where correlation is going to come into play. Okay, and here you can see I've written down the definition of correlation, x and y. It's just the covariance between x and y divided by the product of the standard deviations. Now what does this do for us? Well, what is standard deviation measured in? It's measured in the units of that variable. So if standard deviation x, if x was our age, this would be in years. And if y was income, this would be in dollars. And this would be in kind of a year-dollar product. But anyway, what happens is when we divide that through by the standard deviations, we both get rid of the units, and then we restrict the value of the covariance to between negative and positive 1. Okay, so this is going to be equal to something between negative 1 and 1 always. So we've taken this units problem out, and now we can compare correlations side by side and say one correlation is indeed stronger than another. Let me go back to my Excel book here, and now we'll calculate correlations, and I'll just show you how this works. Okay, so now when I've got age in years and income with the smaller covariance, let's see what the correlation is. Equals correl, array 1, comma, array 2, enter, 0.655. Let's get rid of some decimal points there. That's pretty clunky. We can take it down to maybe 3. Okay, so the correlation is 0.656. That tells us that's positive, so we know they move in the same direction. When age goes up, income goes up, as we would expect. It's fairly strong. It's kind of interpreting correlations is kind of an art. There's no cutoff where we would say that's a strong correlation versus a weak one, but this is definitely a strong correlation. Okay, and let's calculate correlation over here for our different measurement scheme where we're measuring in months. Equals correl, array 1, D2. You can also type these in, which is a lot easier for larger sets, to D11. Array 2 is E2 to E11. Close parentheses, enter. And indeed, we see it's the same value. Let's reduce the decimals. Okay, so you see correlation here is the same regardless of the units of measurement we're using. And we can multiply all these values by 1,000, we're going to get the same correlation because we're dividing by the standard deviation, which is essentially in thousands of units. So dividing through by standard deviation kind of cancels out the differences in the measurement units and gives us something side by side. So covariance and correlation capture the same thing, and correlation actually uses covariance, but correlation is the one that's going to be useful for us making comparisons and making inferences about relationships. So that's what we're going to run with now, and we won't even need to look at the correlation formula again. We'll let Excel do the math for us. But hopefully we have some intuition of what it's doing. That's always useful. So it's always good to understand what's going on kind of behind the scenes with the software. And let's start with 328. So you'll notice this is the same data set as problem 211. It's some data on home, sales, appraised values, square feet, bedrooms, bathrooms. And now we're going to start working with correlations. So the homework says, Part A, create a table of correlations between all the variables. And then comment on the magnitude of the correlation, specifically which of the last 3 variables, square feet, bedrooms, and bathrooms, are highly correlated with selling price. So this is really relevant if you're a realtor and you have this kind of data at hand and you want to know what drives home values. This is a nice small data set, so it'll be easy to work correlations. So the first thing I'm going to do, we're going to set up a correlation table. The first thing I want to do, I'm not going to click and drag here because it's going to be tedious. I'm going to type in values, and our data set goes down to 149. Oh, by the way, I've already frozen the panes at the top. View, freeze panes, freeze top row, and then that kind of acts like a split. I'm going to put a note here. Data runs from row 2 to row 149. Okay, and then we'll put our correlations in. Correlations. And we want to find the correlation between all the variables. Okay. So all I'm going to do is start cutting and pasting these titles. So I'm going to click on appraised value, Control C, Control V, Control V. Okay, we're going to correlate everything to everything. Of course, appraised value correlated to appraised value is going to be 1. It's going to be a perfect correlation. But this is how the table works. We only fill in half of it. Next, selling price, Control C, copy it down, copy it over. And then square feet, copy down, copy over. And then bedrooms, copy down, copy over. By the way, if you don't know what I'm doing, I'm clicking Control C to copy and Control V to paste. Now we're going to use some formulas and do some really easy filling to create the correlations. So we know how to do this already. Equals correl. Array 1 is appraised value B2 colon B149, comma, array 2 B2 colon B149. Now, as we expected, the correlation is perfect. It's exactly 1. To make my work easier, though, I want to just be able to slide and fill this formula. So I want to hold appraised value constant for all the rows, and then change the columns to the next one, selling price, square feet, bedrooms, bathrooms. So how do I do that? How do I hold it constant? I lock the column here. So I'm going to say $B, $B149 for my first array, and then let the second array take a open cell reference. That, of course, is still 1, but now as I slide it over, I'm holding B constant, that's appraised value, and now I'm correlating it to C. If I slide it over one more time, you'll see I'm holding B constant and correlating it to D. Slide it over one more time, holding B constant, correlating it to E, and once again F. Okay, so that's all it takes. I've got appraised value correlated to everything else. Now I want to correlate selling price to everything else. Okay, I've already correlated selling price to appraised value up here, so we don't need to do anything here. We'll kick 1 over. We know this is going to equal 1, but the easy way to do this is going to be to slide down the formula here. Okay, now I want to correlate, let's see, selling price, which is C, so I'm going to change these values to C. I'm going to keep it locked, and I'm correlating it to itself to begin with, so I'll let that one stay C. And it's 1. Now if I slide and fill over, I'm correlating C to D, I'm correlating C to E, that's right, C to E here, and then I'm correlating C to F. Okay, so that's a procedure, and then we'll just finish this up by sliding this down. And now I'm correlating square feet to square feet. Square feet is D, so this should be D to D. And I can slide that, fill that over like this. And it doesn't hurt to check every time. I'm correlating now square feet to bedrooms. Square feet to bedrooms. That should be D to E. That's D to E. Square feet to bathrooms, D to F. So you can see here. Okay, so we're all good. Let's just finish this up. Now I'm correlating bedrooms to bedrooms, which is E. So I'm going to change this to E. Slide it on over, that should be E to F. And then finally bathrooms to bathrooms, just to make the table complete, we know that's going to be 1. That's going to be F to F. Okay, so there's our correlation table. Comment on the magnitudes of the correlations, specifically which of the last 3 variables, square feet, bedrooms, and bathrooms, are highly correlated with selling price. Of course, appraised value is highly correlated with selling price, as we would expect, but which of these attributes, we might say, of the house is highly correlated? Square feet is pretty strongly correlated. Bedrooms, less so, but still, anything above 0.5 is we would consider somewhat strong. Bathrooms, not too strong, only 0.4. But there is positive correlation in all of them. Square feet is the strongest. So we might summarize that by saying something like, let's move on to B. B says create 4 scatter plots to show how the other 4 variables are related to selling price. In each, selling price should be on the y-axis. Are these in line with the correlations in part A? Very easy to create scatter plots in Excel, and all we need to do is select the data we want to pair. So I've selected, actually I'm going to do it this way. I'm going to select the appraised value data here, then I'm going to hold down Control and select the next variable I want to put in this scatter plot, and then I'm just going to go up to Insert. I'm going to click on the little scatter plot icon. I'm going to do a basic scatter plot, and that's it. Okay. And by the way, we're going to clean up this chart a little bit so it's visually much better. So I know that selling price is on the vertical. I'm going to do a little chart design. I'm going to add chart element axis titles, and I'm going to call this selling price. Let's also go ahead and do that. Chart tools design, add chart element, axis titles horizontal, and let's go ahead and type in appraised value there. Okay, now the title is going to be appraisal, let's say. We don't need to be so detailed on that. The only other thing that would make this chart more useful or visually better is to cut out, there's a lot of extraneous white space here that we don't need. So what we can do is tighten up the range of the axes. So I can right click on the x-axis and click format axis, and then I get my axis options, bounds, minimum, maximum. Let's change the minimum, and it looks like there's nothing below 100,000. So let's go ahead and just type in 100,000. That's better. Now let's do the same thing for the vertical format axis, and there's really nothing below 80,000 here. So let's put in a minimum value there of 80,000. So there's all kinds of formatting we can do. I don't want to dwell on formatting, but it is important, especially if you're printing things out or emailing things to someone. You want to have it very readable and kind of pretty. Okay, but we know how to do it. So there's price versus appraisal. Let's do a couple more of these. We maybe don't have to do all of them right now. They're pretty easy, but let's do at least one more so we can get the hang of it. So we've done price versus appraisal. Okay, so next is selling price versus square feet. So same procedure. I'm going to select price, I'm going to hold down control, select square feet. I'm going to insert a scatter plot. Okay, I'm going to put this down here, and when you finish your homework, I want all these charts stacked up here in this fashion. But we've got a problem here. The book says selling price should be on the y-axis. We've got to do, Excel didn't do it the way I wanted to, so I've got to tell Excel to fix it. So this is actually kind of a pain in the rear, but it's important. We want these all to be formatted the same, so let's work through how to do this. So to change this up, you're going to click select data. Now you're going to be tempted to click switch row column. Now look what happens when you do that. You get something really whack. So that's not what we're going to do. Right click, select data, and basically what we want to do is reset this up inside of this chart wizard. So I'm actually going to select series 1 and click remove. I'm going to start all over. I'm going to say add. Series name, selling price, series Y values are, I want this on the Y axis, so I'm going to go back here and select selling price. Entries, and I'm going to hit OK. Okay, let's just check and see. Okay, now my y-axis looks right. It's got the selling price. It's got the selling price range on the y-axis. So far so good, but we've got to do something else. So I'm going to select data. I'm going to select selling price again and hit edit again. And now for the x values, I'm going to select the square feet entries. These are the x values that correspond with the y values of the price points. So if I hit OK there. Let me go back up to where my chart is. Okay, now that's what I want. I can clearly see that's my square foot range. Most of them are clustered here between 1,500 and 2,000. I've got some outliers way up here at 2,500 and down here at 1,200. So yeah, that's correct. Now, clean up my title. This is going to be price versus square feet. I'm going to add some axis labels, remember? I'm going to just go up here to chart design, add chart element axis title, vertical. This is once again titled selling price. Let's go down here, chart tools, add horizontal, square feet, and then we'll clean up the range, format the axis, and let's see, for selling price we used 80 above, so let's stick with that, 80,000. And then for square feet, let's format that, and there's nothing below 1,000, so let's use 1,000 as the minimum here. Okay, so there's price for square feet, and there's how to switch axes, and you can go ahead and wrap up doing the scatter plots for price versus bedrooms and price versus bathrooms. So when you turn this in, you should have 4 scatter plots. They look just like this. Okay, let's move on to problem 333, and we're going to enter a whole new world of Excel. Some of you are familiar with, but I think this will be new, and it'll be scary at first, but trust me, this is going to be perhaps the coolest thing you learn in the whole class. And hopefully a Excel tool that'll really differentiate you from the novices. Problem 333 says solve problem 1 with pivot tables and create corresponding pivot charts. Okay, so let's go back to problem 3.1, page 85. And it says it gives us a table of the gender and nationality of the MBA incoming class in 2 successive years at the Kelley School of Business at Indiana University. That must be where one of the professors that wrote the book is from. And then, okay, so that's what we're looking at here. And then it says for each year separately, recode nationality so that all nationalities with a count of 1 or 2 are listed as other. And then we're going to go on to create a crosstab. So basically what we want to work with here is we kind of want to say, for males, how many of them are from the US versus other countries? Or for people from the US, how many are male versus female? Just kind of looking at this, there's a lot of entries. That's hard to know. So we need to organize it. That's basically what we're going to do. And I am going to work you through problem 3.1, although I'm only requiring you to do problem 332, so I'm only or 333. I'm only requiring you to do the pivot table, but I want to show you crosstabs for 2 reasons. One, it is something that you might want to have some familiarity with. You might use it. The main purpose, though, is to show you that pivot tables does the exact same thing and does it a lot easier. But I do want to show you crosstabs. I'm going to quickly work through problem 3.1, and this will give us a little bit of practice with some lookup, count, and if functionality that's pretty good for you to know anyway. And then we'll jump up and do it with pivot tables. You'll see it's going to be a lot quicker and easier, and it'll accomplish the exact same thing to do pivot tables. What I'm going to do is collapse that down, and notice that I'm skipping from D to H now, just because I don't want to visually be distracted by that 2009 data, but I can always bring it back the same way I hit it. Okay, I'll work out here. So we want to recode nationality so all nationalities with a count of 1 or 2 are listed as other. That's going to be Vlookup. But before we can even do that, we need to make a Vlookup table. Because it's going to be count based, I need to make a count table of nationalities. So over here, way off to the side, I'm going to make a little lookup table, count table, nationality, and count. Okay, so the first thing I need to do is find out how many unique entries I have for the nations. And this kind of harkens back to what we did in a chapter 2 problem. I'm going to use my nifty tool here of sum product 1 divided by count if C3 to C229. Actually, that should be C2, I believe. Range and C2, C229. Okay, and that tells me there's 20 unique entries. The other way to do that would be to alphabetize these and then count them up. So I know I'll need 20 things over here in nationality. Actually, I just realized the data starts at C3, so let me fix that. That should be C3 to C229. 19. Okay, so I've got 19 entries for nationality. How do I make sure I get them all? I think I'm going to do a sort here. I'm going to sort them A to Z, yet let Excel automatically expand that. Okay, so I'm just making sure I get all 19 of them. Let's try that in. Okay, I'm tired of individually cutting and pasting. I got as far as Italy, so I'm going to use a little trick here. I'm going to select the next thing is Japan. I'm going to hold Control and select 1 of every remaining entry. Mexico, Nigeria, Pakistan, Peru, South Korea, Taiwan, Thailand, USA. I'm going to hit Control C, scroll back up here, Control V. And yep, that's 19. Okay, so I know I can delete these now. So I know I've got everything I need up here. And now the count. How do I get a count of each one of these? Well, I could go over here and look. For Austria, it's easy. There's 1. These are alphabetized, right? These are alphabetized, so I know it's 1. But how many Indias? I don't want to try to count that. Excel do it for me. So this is going to be a simple count if function. Count if. Range. This is where all the nationality entries are. I'll go ahead and click and drag that. Come back up. And then the criteria. And by the way, let's lock the row values there so when we slide this down it stays put. The criteria for Austria is Austria. I could type it in or I could just do a cell reference. Watch this though. If I do a cell reference and let the criteria, if I leave that open to slide, I've locked the range of, now I can just slide this bad boy all the way down. Boom. Okay. So I've got my counts. I know how many entries I have for each country. Now we can think about recoding nationality so that all nationalities with a count of 1 or 2 are listed as other. So basically we were looking for the countries here that are the most highly represented. So the countries that have just 1 or 2 students, we're going to group them all together as other. So if we're going to create a new column here called Recode Nationality, Let's expand our cell width there. And if we're recoding, that's going to be a Vlookup. But this one's going to be complicated but cool. So let me show you what we're doing here. Okay, and this is going to be a multi-step process. It's actually going to be an if with the Vlookup inside of it. Because what I want to tell Excel to do is say, okay, look at all of these, and if there's only one or two, I want you to stick the word other in there. Well, we could do that with just an if function. But if there's more than two, I want you to keep the name. Right, so we're going to use a Vlookup in combination, because this over here can be my Vlookup table, and then it can say, well, is the count 1 or 2? If it is, then we'll replace it with other. If the count's greater than 2, like China for instance, it'll use the word China. So let me show you what the formula we're going to use here. It's going to be a if with a Vlookup nested inside. Okay, so the logical test for my if is a Vlookup. Lookup value is going to be here. And I'm not locking that because we want that to slide down as we slide the formula. Table array, now is this again. Now that we want to lock, at least the row numbers, because we don't want that to slide when we slide the formula. Column index number, we're looking in column 2. For approximate matches will work fine here. Either true or false will probably work the same here because we've copied everything exactly. And now my logical test of my Vlookup, well, we want to see if it's less than 2. If it's less than 2, the value of true is going to be the word other. Value of false, if it's greater than 2, it's going to be itself. So I'm just going to put the cell value in there. Well, let's see if that works. Okay, yeah, there's only one entry for Austria. We know that's true because this is alphabetized and it only pops up once, so it shows us other exactly like we wanted it to. Does it work for Brazil? No, Brazil's only got 2. I want it to show other, but it's showing me Brazil. Well, I've got a little flaw in my formula here because I'm saying exactly less than 2. And it's not less than, it's equal to. So well, I could put a less than or equal to. I don't know how to do that off the top of my head, but I know that if I change that to a value just slightly larger than 2, 2.01, now 2 is less than that, so it'll show me other. Whoops. And when I drag this down, now China's more than 2, so it's going to show me, China's over here 14, so it's going to show me China. Okay. And let's just double click on the crosshair to fill that all the way down. Okay, it's showing me other for the small countries, it's showing me the country name for the large countries. Okay, so that step is completed. That's a hairy kind of if Vlookup thing, but it shows you the power of combining formulas to start organizing stuff exactly how we want it. Okay, next step. For each year, this is B of problem 1. For each year, create a crosstabs of gender versus a recoded nationality in an associated column chart. Okay, remember crosstabs is kind of the primitive way of doing what we can do easily with pivot charts, but I want to show you how tedious this is. It's actually not that hard once you get the hang of it, but there's kind of an intimidating formula called count if. But let me just go over here and I'll set up a crosstabs. Okay, I'm going to type in label, create a little table range over here. We want gender versus nationality, so I'm going to split the columns into male and female, and then I want all my nationalities down here. But I actually only want the ones with 2 or more. So anything that's 2 or less, I'll put other. And then I'll just copy over the ones that are greater than 2. And the easy way to do that is just going to be to select the ones that are larger than 2. So I'll select China, I'll hold Control, India, Japan, South Korea, US, Control C, Control V, and then I'll just type in other here. Okay, so now what I want to do, I want to know how many of all the entries from Chinese folks, how many are male, how many are female. Same with people from India, Japan, etc. So what I'm going to tell Excel to do is say, look at all the male, look at the entries here in gender, and for the males who are from China, so if it's male and China, count it. If it's not, don't count it. So that's a count if. If it's this and this, count it. If not, don't. So what are we going to do? We're going to do count if. Now, it's more than one criteria here, though, so it's not just count if, it's going to be count if S, and that means there's multiple criteria in our counting formula. Okay, and it's actually pretty simple once you get the hang of it. So criteria range 1 is going to be whether it's male or not. So for criteria range 1, I'm just going to drag and select all the gender entries. And because I'm going to drag this to populate this whole crosstabs chart, I'm going to lock this in. I'm going to lock it in both vertically and horizontally. So I'm going to put dollar signs in front of row and column. And then criteria one. What's a criteria? Well, here in the first column of my crosstabs, it's for male. So I'm actually going to select that. Find only male. Now when I slide this over, I want it to slide over and pick female. So I'm going to lock the row, but not the column. Okay, so what I've just done is told Excel, look only at the gender entries, and then find the ones that are M, and then something else, not criteria range 2. Then I'm going to say, look at all the nationality entries. So criteria range 2 here is going to be all the nationality ones. C3 to C229. Probably would have been easier to type that in. And again, this I want to lock down completely, because when I slide this over, I want it to stick in just those entries. So I'm going to lock this completely down. $C, $229. And what I'm looking for over here now is China. And I want to do this by cell reference. I could type it in, quotation marks China, but if I do it by cell reference, when I slide this formula down, it'll slide down and pick India for the next row and then Japan for the next one. So I want to let it slide row, but lock the column this time. So I'm going to put $I, and I should be able to close my parentheses. I've got 8. I know from looking at my, I worked this out previously. I know I'm right. And now let's see if it works to fill this bad boy. So let's start by filling it down. And oh, I see I made a mistake. Why do I have 0 and other? Oops. I should have picked D where my recoded instead of C. I can easily fix that. My second criteria range, let's just change the C's to D's. Okay, now let's refill that. Everything's the same except other now has 13, so I know I'm on the right track. Now let me see if I can take all these and just fill them over. And if I let my my first criterion slide to now my first criteria for my first sort is now K2. Everything else is the same, and that should work. And indeed it does. Okay? And all these numbers are right. So that's using count ifs and crosstabs. And it tells me this breakdown of male, female, by country, or by, whatever. If we could have multiple entries here, and some of the data files we'll work with will have multiple things, and we'll want to know one by another or one by another. So for instance, if we had data on the age, we could also say how many 30-year and older males are there from China or from India or from whatever, or how many 25 to 30-year-old females are there from China, so on and so forth. So we could slice this up any number of ways. Crosstabs, like I said, is kind of a primitive way to do it. Pivot tables is the easy way. One more step though before I jump to pivot tables. It wants us to create a column chart. Well, that's easy. Select all of this stuff, column chart. Done. Maybe change the title a little bit. What would be an appropriate title here? This would be, and we could do some formatting here, but we don't need to spend time on that. That's good enough. Then it asks us, there seemed to be any relationship between gender and the recoded nationality. And then there's a pattern the same in the 2 years. Well, you'd have to do the 09 data yourself. We can skip that for now. There is some patterns here. We see that for the U.S., South Korea, India, and other nations, there's a lot more males than females, a pretty high ratio. But look for China, and I should have Taiwan in here. I made a mistake. Oh, I goofed up. I can fix it though. Let me do this. I'm going to cut and paste. I missed Taiwan. There we go. The cool thing about Excel, man, check that out. When I added that in there, copied the formulas, it assumed I wanted the same formula as my count ifs, and it also added it to my table automatically. Awesome. How cool is that? Okay, so let me just make sure. China, India, Japan, South Korea, Taiwan. Okay, yeah, now that's correct. Okay, so that was an error I made. Gotta be careful about getting all the data in. But the point stands that China and Taiwan have a much more even ratio of males to females. So we do kind of see some geographic breakdowns in our male-female ratios, and people are going to be interested in those kind of things. Okay, but now let's jump up to problem 333, which says, do that same thing with pivot tables and create corresponding pivot charts. It's sick how easy this is with pivot tables. So let me show you how to do that. Now, to make the pivot table, I'm going to select all my data, now including the student number here. And it's important I have something other than just gender and nationality here, so I can have the pivot table do some math on this data. But I'm going to select all that data. Whoops, I need to select the headings as well. Let me try that again. Okay, I'm going to select all that data, including the headings. I'm going to insert a pivot table. Okay, I've got my range already selected. Existing worksheet, we'll pop it in right here. Okay, and now we get this pivot table kind of wizard over off here to the right. First off, what are we trying to accomplish? We're trying to accomplish the same thing we did in the crosstabs. So we have nationality by row and then gender by column. So I want gender and then I want recoded nationality, right? So I want to simplify all the other lists of countries that aren't highly populated. Okay, so now I've got everything in columns. I want to move gender up to, I've got everything in the rows rather. I want gender up in columns, and I've got recoded nationality in rows, gender in columns. Okay. But there's no numbers here. There's no numbers, right? Oh, I've got to have a student. I've got to select students, and then that'll pop up here in the values. And I don't want sums. These are just arbitrary numbers. I want a count. So I'm going to pick the drop down here on the values, and I'm going to go to value field settings and then change sum to count. Okay, and that's exactly what we're trying to accomplish. And let me kind of compare. Now here I've got male and then female. Here I've got female then male. That's going to be pretty easy to switch up though in my crosstabs. There's a couple of things I could do. I could either do the column labels here, sorted A to Z. Oops, I want to sort Z to A. So now I've got male, female. I could also right-click on this, and then there's a move, and I could move it down. So that switched it back around. So I click M and hit move up. So now I've got male, female, and you'll see I've got the same numbers: 8 males from China, 8 males from China, 36 females from the U.S., 36 females from the U.S. So on and so forth. And then now the cool thing the pivot table does automatically is totals these up over here. So my total from China, my total from India, Japan, etc., my total males, my total females, and then my grand total males and females from every country. Okay, then finally the problem says express the counts as percentages of row totals. Wait, first off, okay. So next we want to create the same kind of chart we did with our crosstabs with the pivot table. Okay, let me go up here to Pivot Table Tools, Analyze, Pivot Chart. Okay, look at that. Isn't that exactly what we just created? Bam. Okay, so this is a pivot chart, which is the same thing. Now, it was easy enough to create the crosstabs chart once we created the crosstabs, but it was a pain to create the crosstabs, right? Remember, all that count if hairy formula. So down here, we do the exact same thing with the pivot table, pivot chart. Pivot table is going to be a very powerful tool, and we want to really start getting the hang of them. So one other thing in the problem, it says express the counts as percentage of row totals. Let me show you how to do that. You go to the data, right click, and then show values as, and percent of row total, and that basically is telling us for each row what percent is male, female, and of course the total is going to add up to 100. So for China, they're 57% male, 43% female. Roughly US is 72% male, 28% female, so on and so forth. I think it's a little more useful to show values as percent of column totals. And what that tells me is that China males are 5% of all males in the class. US is 55% of all the males in the class. US females are 60% of all the females in the class. Okay, and then US is 56% of all people, male and female. China are 6% of all the people. Okay, so there's a lot of different ways you can slice this stuff up. Okay, we've only begun to use them. We don't want to complicate it with anything else.
Okay, so moving on to problem 336, and this one just says solve problem 4 with pivot tables and create corresponding pivot charts. Express the counts as percentage of row totals. Okay, so if we back up to problem 4, which is on page 85, it talks about that supermarket transactions file, which I've copied in here. And this is a huge file, you'll notice, with over 14,000 entries. So it's almost pointless to really go through this just visually. So we've got to use an Excel tool. Unfortunately, it's very easy to slice and dice this with pivot tables. So what it asks us to do in problem 4 is says to understand which customers purchase which products, create a crosstabs and associated column chart for each of the following. And then it says for each express the counts as percentages so that for any value of the first variable listed, the percentages add to 100%. And then it asks us to do gender, marital status, and annual income versus product department. Okay, so that's going to be all be really easy to do once we get this in a pivot table. Now to select all the data, we're going to select the top left-hand cell here. And I could click and drag. It would take me minutes because the data set's so long. A trick I can use is to scroll down manually to the end of the data set, keeping that top left corner selected. Now I'm going to hold Shift and select the bottom right corner, and boom, I've got it all selected. Then I can go up to Insert Pivot Table. I've got my range selected, and we'll put it in the existing worksheet, and I'll just select from my location right over here next to the data range. I'll hit OK. And now we've got the pivot table wizard over here. So what do we want to show? Well, the problem says gender versus product development. So we need gender. We need product department. Marital status versus product department. And annual income. And then to get my counts of customers, I'm just going to use customer ID, and that'll be in value, and it's not going to be sum. We're going to change that to count. Okay, and then we'll scroll over here to find our table. Now we've got to rearrange some stuff. We want gender, marital status, and annual income as the rows, and then product department, we'll move that over here to columns. Okay, and actually to simplify this, let's do these one at a time. So I'm just going to do gender first. This is basically all it wanted us to look at. And now I know for, let's say, baking goods here, there were 1,072 purchases, of which 520 were females and 552 were males. Now it's not very useful to look at the numbers. It's a little better to look at percentages. And the problem asks us to do the percents, express the counts as percents of row total. So I'm going to right click and then show values as percent of row total. Now what is that telling us? So notice you have to scroll way over to get to the edge of this. There's a lot of these categories. Well, it tells me of 100% of purchases, 1.87% were females purchasing starchy. I have 100% rather of females purchases. So this is all females in top row. 1.87% of those were starchy foods. 13.77 were produce, etc. Of all males purchases, 2% were starchy foods. 14.6 were produce. 4.85 were deli, and so on. Okay. Now here's all purchases, and of all purchases, almost 2% was starchy foods. 14.1 was produce. 0.4 was carousel, etc., etc. So right now we're just learning to use this tool. We're not going to try to do any in-depth analysis with it, and that's really all we need to do. And we want to do that with gender, and then we'll add marital status and annual income, and then we can really just kind of expand there's a couple ways to do it. We could create 3 different pivot tables, or we could just expand our pivot table. So if we click all 3 of these and put them into one pivot table, notice what it's going to do is it's going to start off with whatever's on the top down here in rows. So let me move gender to the top. Then I've got marital status, then income. So it's going to start categorizing by gender, female, male. And if I click these, it'll expand. And then it'll sort by the next thing, which is marital status, so married, single. And then it'll sort by the next thing, which is annual income. So it's already binned the income for us into these categories. Let me just show you that when we have gender, marital status, and income together, it's sorting first by gender. So it's all the female entries are up here, and then all the male are down here. We can expand and contract those as needed. And then we're next by marital status. So females who are married are in this area here, and I can expand and contract those as well. And then females who are married with this income, with this income, and this income. Okay, and then here's a percent of row totals that each subcategory spent on each good. And you'll notice the rows all sum to 100. And then the columns, down here, the columns don't sum to 100 because this is basically saying what percent was this category of all the spending. Again, the rows sum to 100, not the columns. So this 6.95 here, that is canned foods. So that says canned foods is 6.95% of all sales. And then we can go and break down the fact that females as a group bought 7.13% of all canned goods, and females making 150,000 plus bought 10.3% of all. We're 10.3% of canned goods sales. Okay, and so on and so forth. And I think I don't want to do too much time on pivot tables right now. We'll come back and get into more detail. I just want us to learn how to use them, and hopefully this is a good intro for that. And then in problem 340, you're going to be able to try some pivot tables all by yourself in part B of that problem. So best wishes on the homework. Be sure to use the forums. Email me if you have difficulties, and we'll get this problem set done through the end of this week. along with Chapter 3 quiz, and then we'll kick it into high gear next week.